Hi and hello to this video. So last time we left off with our triangle and basically we just discussed how to pass data into our triangle via vertex buffer. This time we're going to go a bit further. We don't want to draw a triangle anymore, actually we want to draw a quad, and after that we want to actually learn a bit about the index buffer, and it's going to be it for this video. So first of all, you might ask how we draw a quad. And for that, let me just do one small change because it will be easier to discuss it then. So in our program, we had this basically a triangle, and then this last one, which is a middle one, I'm just going to move it to the left. So to minus 0.5. If I run it now, let's try this. Yeah, we want to have this. So how do we go about drawing other shapes in our with WebGPU? So basically we had this point which we're going to call V1, and then we had V2, right, if you remember, and then we had basically V3, which correspond exactly to these points here, right? So we have V1, V2, V3. So now what we want to do is, let's just bring this up here somewhere. What we want to do is, just we're going to continue from V2. So we're going to have V2 two times. We're going to some new point, which we're going to reference as V3, and then we're going to connect back to this one. So, but actually this is not going to be V3. We can call it V4, V3 here. So we have V0, V1, V2, V3, V4 here, and then we can say V5 here, right? And that's going to make our second triangle, and that's how we're going to draw further on, right? We just need to specify basically data for true triangles. So let's do that real quickly, and this should be easy enough. So let me just check once again points. So we need bottom right, top right, and top left. All right. So let me just clear this. Right, that's a shortcut. So actually they were not zero indexed. I indexed them from 1, but regardless, we just need 3 new points for the second triangle. So, and I mentioned that we're going from top right, which is same as this one, right? Because the middle one was, sorry, not top right, bottom right. Bottom right, so we can call it V4. Then we need top right, so we can just copy paste this, say V5. And here it's going to be 0.5, and then we need the top left, right? So we can call this one V6. This top left, exactly. And if I try to run it now, we're probably not going to see anything because of the one bug that I forgot to do last time. And if we go to our unlit render pipeline, here we hard-coded this vertex count tree. So this cannot be hard-coded. We're actually going to need vertex buffer, and we can call this property vertex count. And we can create that property on a vertex buffer. So let's just go to our vertex buffer. Here under size or wherever we can say public int vertex count. So we can make it public private set, and then maybe we can assign it here int vertex count. And by default I'm just going to place it to 0 because we could use vertex buffers for other things, and this parameter might not even be important. But here I'm just going to assign it, and then in our program, when we create it, we can just say 6. And if I try to run it now, we should have something. If we compile, actually not here, rather it's here, right, when we initialize it. So if I try to run it now, we do have our quad. So hopefully that's clear. It's not that hard, right? We just have to specify our vertices, right? We had V1, V2, and then, sorry, V2, V3 here. That was our first triangle. Then we specified V4 here, which is just duplicate. Then V5 here and V6 here, right? That was our second triangle. Cool. Now, the problem with this approach is, as you can see from our data, let's just get this from the screen. As you can see from our data, some of the points needs to be duplicated, right? And you can see it from the image as well, actually. I don't have to like show the data here. You can see it from the image, right? When we had our triangle, right, we had this, and then we duplicated this point, right? And then we duplicated this point. And we can avoid it. We can just specify 4 points, right? Let's say V1, V2, the order is right now not important. This is just for explanation, V4. But we can actually draw them by actually using indices, right? And for the indices, we create the index buffer, and that's what we're going to do soon. But we could imagine in these indices, we could say something like 0, 1, 2, right? And then 0 is referencing this one, right? This one. 1 is referencing this one, and then 2 is referencing this one, right? And in order to draw second triangle, we can specify once again 2, right, to reference this one. Then we can specify 3 to reference, let's say, this one, right? And then finally we can specify this one is in this example 0, right? So you can see here we have 1, 0, 1 and 2 as indices, right? And then we have 2 again, 3 and 0 again, and that makes second triangle. So this drawing, it's kind of horrible, but you will understand it once we do it. So let's get rid of this and start with our index buffer. So basically this is called index buffer or indices buffer, and it just points to basically these vertices, right? So let's start with it, and then it's going to become. So for our index buffer, let's just go here into buffers and just let's create class index buffer. And here, what I wanna do is actually, I'm just going to copy vertex buffer because it's very similar. So I can just basically copy all of this, go here, and then we can just change name to index buffer, right? The index buffer is very similar to vertex buffer. We're just going to paste indices in, and you're going to see what I mean. I'm just going to explain, but index buffer, let's just call it index buffer. So we don't have to change this either. Here I'm just going to call this indices count. I think it's more appropriate. For our data, obviously we cannot paste float for our indices. It has to be integer, but we can use unsigned integer or unsigned short. So short is 2 bytes, integer is 4. We can use short because our data is not going to be that big and it's a bit more optimized. Vertex count we don't care about here. So here it's size of view short. Sorry. And then we're going to have another method, and this was previously called create, right? So I just renamed it to create vertex buffer. So you can just rename this in buffer util. You can rename this create vertex buffer. So basically going to our index buffer, we can call it create index buffer. We can paste in data. So indices count is just going to be our data.length, the length of our data, and we just have to cast it because here I said uint. And the reason I'm doing uint instead of int is just because it's easier to work with WebGPU library because it actually expects this type. So that's the reason why. So going further, we just need to create this index buffer method. And so in our utils, similarly, I'm just going to copy paste this, be very lazy. I'm just going to call this create index buffer. So what do we need to do? We need to paste that use short data. Here size, be very careful. If something is wrong, it's probably the size. Here buffer usage, it has to be index buffer. And here it has to be use short, right, pointer. And that's it. So let's see what do we need further. So further we have to modify this unlit render pipeline render. Previously we were just taking in vertex buffer, but let's create sort of an overload that can take index buffer as well. and let's just make it nullable. So if you want to use just vertex buffer, you can. If you want to use index buffer, you can as well. So here I'm just going to say, and here, let me first actually just break this method a bit so that it's easier to see. We can say if index buffer does not equal to null. If we have an index buffer, we're going to do something else we can draw with this. So let's just complete this else statement and then I'm going to explain it. So if we're doing index buffer, and if we have index buffer, we cannot use this encoded row. That's if you don't specify index buffer. So there is very similar called method, which is called render pass draw indexed. So that's for index buffer. So here we're just going to say index buffer dot indices count, and it has a bit more parameters. So instance count is 1, and then it has parameters base vertex first instance first index. So here it has 3 parameters, and these last 3 are just basically offset. So the offset into index array, the offset into vertex array, and then the first instance. And we still haven't passed in similar to what we had here, right? When we were passing this vertex buffer, right? If you remember, there is similar function just that passes index buffer as well. So WebGPU and pass encoder. So set index buffer. So we can just set it. So we're going to need this as a first parameter. So the slots, here we have slot, but for index buffer you can only really have 1. So we can just paste index buffer, the buffer here. Then the format, this is important. So index format. So the only relevant for you are really this uint16 and uint32. Uint16 is basically 16 stands for 16 bits or 2 bytes, right? A byte is 8 bits, so 2 bytes or 4 bytes, right? If it's 32. So we used ushort, so it's uint16. Be very careful about this one. This parameter has to be correct if you use ushort. If you used uint, then it's 32. And what was the last parameter? It was probably some offset, exactly. So offset is 0, we don't have any offset. And then the size, I think on our index buffer we already calculate size, which was just length of our array times size of ushort. And that's it basically. So let's see what do we need to do to paste that in our program, nonetheless. So here we had 6 vertices, but what we want to do is just have basically 4 vertices, right? This was v1, and then let's call them v2. So I'm just going to 0 index this one. So basically we had a triangle that goes like this, and then we had the second triangle which was going to from v1 to some new v3, and then over here, right? That was the second one. So let's see if we can do that. If I remember correctly, and this is 0.5, 0.5, 0.5, so it's our top right corner, so we care about that one. And I'm just going to rename this to v3. It's going to be way easier because everything is 0 indexed in programming, so I think it's better if we just 0 index it. And then here we can just create our index buffer, pass our engine in, and then we can say index buffer initialize new short array, right? So what are our indices? If I just bring this tool up, so basically our index is going to be 0 for this one, 1 for this one, and 2 for this corner right here. So we can say 0, 1, 2. So that's some triangle T1, or better yet T0. Let's keep 0 indexing. And then for the second one, we just have to draw this triangle, which is now going to reference right, this vertex v1, bottom right one, So then we're going to reference v3 and then v2. So we can say 1, 3, 2. 1, 3, 2. That's our triangle T1, some triangle T1. And if we go further, maybe I can clear this up. It's not relevant anymore. We just have to paste it in here. And then we have to dispose of it as well. If I run it, and it still works. So with that said, that's it regarding this video. For the next time, we're just going to cover maybe texturing, maybe global data. We're going to see, but hopefully this was all clear. I think everything should be clear by now. If not, just revert the video and it should become clear on the second view. That's it. So folks, if you liked the video, please like, subscribe, maybe leave a comment, and until next time.